to send you a bio.
Brad McCarter is a graduate of a very small, unimportant school in Tennessee. He moved to the Minneapolis area under the stern advisement of his wife, Jen, a native of Minnesota. He has been at Braun Intertech since the move in 2010. Funny story, Brad and I started like 2 weeks apart way back when. He is currently a director / senior engineer working with a mix of private development, public transportation, and medical projects. So if everybody wants to give it up to Brad McCarter, thank you, sir. Appreciate it.
Thanks, Gary.
You want this or it's up to you. That one's for that. So if you want to hold this one at the same time, double dip.
I'm already double dipping because I got notes here and I got slides
If
here.
you don't want to
so-
use it, by all means, don't.
Can everybody hear me? No? Oh. Hello? Can you hear me now?
Yeah.
All right. So as Gary said, we're here to talk about North Loop Green, the newest tower in Minneapolis. So that is the tower here, just outside of Target Field. So just not.
Forgot to say one thing. Let's thank Braun Intertech for being the sponsor of tonight's event. Thank you.
Not working.
Clicker's not working.
Clicker's not working. I'm gonna click and you're gonna move. All right, so before we get into the tower, I thought I'd just throw a little about me. A lot of you know me, but a lot of you don't. So this is my family here. It's my wife, Jen, of 18 years, my son, Eli, he's 15. My daughter, Emily's 12. Teenagers are tons of fun. You know, I'd rather be driving a Titleist. If I'm not driving a Titleist, I'd like to be fishing. I developed a little habit of bourbon and cigars over COVID. And I went to the University of Tennessee. So, been in the industry for about 20 years now. So, yeah, just a little background on myself and where I'm coming from here. So North Loop Green, project introduction, kind of some overview. The tower is 415 feet tall. So it is currently right around 20th in the city. So I guess that counts as a skyscraper, kind of a mid-range skyscraper. For reference, the Fauché Tower is 448 feet, and the tallest building, the IDS Tower, is 792 feet. So the building consists of a 4-story podium with a 36-story residential tower and a 14-story office tower. So the residential tower is a concrete structure. The office tower is a steel structure. So kind of the unique feature about the building is the amenity terrace that connects the two between floors 18 and 14. So yeah, so that's the tower in a nutshell. It's currently set for completion in the next few months. So I think they're shooting for a June opening. So project team. So the owner is Hines. For those of you aren't familiar with Hines, it's Hines with an S, not the ketchup moguls with a Z. So they are a very large global developer. They're in 30 countries worldwide. They're one of the largest in North America. I think I saw they have $160 billion of real estate assets in North America alone. So they are a very big entity. They're not as big in this market, but they are a pretty big time player on the global scale. This is their third project in the cities. They bought a huge piece of land and this is their third building on that site. So architect was ESG, structural engineer was WSP out of Chicago. Civil engineers Laux, the general contractors Kraus Anderson. Foundation contractor was Bolander. Concrete was done by Northland. The post-tension concrete on the residential tower is Kelleher. And the steel erector is Emmerich. So just kind of an overview of who all was involved, who built the thing. So really good A team, makes a project go really well when you have a team like this involved. So our services performed. We started working on this job in 2019. So we've been working on this job for 5 years now. We've done all the geotechnical, 3 rounds of borings, plus some additional testing, environmental phase 1s, phase 2s, wraps, all of the environmental. Packages, pre-construction condition assessments, vibration monitoring, tunnel inspections, special inspections and testing with steel and concrete and all of the things that go into the building envelope, roof davits, some structural assessments. We've done all the fire stopping. That's the only piece of the puzzle right now really that's still ongoing in our world is the fire stopping. So, and then various tenant improvements, as you know, in a big building like this, you kind of, once the building goes up, now you start kind of modifying everything for all the people moving in. So site location, as you can see, this is actually Project North is going straight up, but actual north is going like this. For purposes of easy plans, everything was done by Project North and kind of skewed just a little bit. So you'll see this, it's not quite north, but this is the way we looked at the site. So right next to Target Field, kind of crammed right in between 5th Street and 4th Street, overpasses right here in the middle. So hit the next one. So the neighbors, when you put this site in the middle of downtown, I don't think you could have collected another group of misfit neighbors. It's got, I mean, everybody involved. It's got the BNSF and the North Star corridor, along with Cedar Lake Bike Trail on the north side. It's got the Twins and the Poleads over on the west side, along with the overpass of 5th Street that's controlled by the city. On the east side of the building is the MnDOT overpass for 4th Street, and then there's the other viaduct of 3rd Street over here. In addition to MnDOT and the city and the rail and all that, you also have a Met Council utility line that runs on the south side, and historic preservation with the Crane Building and Minneapolis Preservation Alliance to keep the building, everything intact. So when you start talking about all the different players, you can see why this probably took them years to work through red tape and get development started. That's a lot of coordination, a lot of neighbors to make happy. And then at the end of the day, you also have this lovely Bassett Creek watershed and the tunnel that runs through the site. Hit the next one. So for those who aren't familiar with it, Bassett Creek used to run through Minneapolis. So in pink here, you'll see back in the 1800s, they took the creek here in the west, so coming from the west suburbs, took it underground in a tunnel that runs all through the North Loop back out of the Mississippi River. So back, I think the Reagan administration approved the final funding for this, but they rerouted the tunnel. They abandoned this one. So now the tunnel only gets basically backflow from the Mississippi River, but the creek actually flows through here. Hit the next one. And our site falls right there. So you can see it's right along the alignment of this new tunnel that they installed in between 1978 and 1992. So here's the tunnel when they started putting it in. It's a double barrel box culvert moving to a single barrel box culvert. And then past the site, it's a cathedral arch. So at the next one, this is where the tunnel runs through the site and under the building. So this tunnel is 14 feet in diameter upstream. Then hit one more. We've got a drop structure right in the middle here. So upstream, it's a 14-foot diameter culvert. Downstream, it's an 18-foot culvert. It's got a 23-foot vertical drop at that point. So the tunnel runs along at a top elevation at about an 807, drops 23 feet, and then keeps running as it continues on to we'll call it Project East. But yes, so that's a challenge, obviously, a known condition going into the site, but on top of all the neighbors, they have a huge tunnel running under the building. The next one. So just an overview, Minneapolis geology, as most of you are probably familiar with. Below the buildings in the central business corridor, you kind of have the Platteville limestone, Glenwood shale, St. Peter sandstone. As you get towards the river, you have the Mississippi River Valley and the alluvial deposits. So one would think that's what we're dealing with, right? We're going to go in And this is what we have. And I guess in a nutshell, that's why we all do borings. This is about to be kind of why we do all the evaluations that we do. But if you'll go to the next slide, this is our boring program that we've done through the past. We did about 2.5 years of drilling in 3 different phases. We also used a bunch of borings from previous evaluations. I believe the blue ones were Army Corps of Engineers who installed the tunnel. The purple ones, or I guess these are blue. Those are from the Army Corps of Engineers from 1988. Everything else was done in various phases by us. The purple is done during the utility construction and neighboring T3 building. And then we did several phases of borings, starting with the green borings, moving to the red borings. We did conventional SPT borings. We did pressure meter testing. We had a whole variety of evaluation techniques. And then we got these 2 borings on each side of the site that I'm just going to pull up for reference purposes, just to show you. We're not going to go through the whole boring log report, but we'll hit a couple of them, one on the east side and one on the west side. And you'll see on the west side of the site, we hit the typical urban fill. And then we had all these fat clays from the alluvial deposits, very soft. These go down to depths about 50 feet. Bedrock on this side is at about 115 feet to hit sandstone. And then you move over to the east side of the building and you've got urban fill limestone at 9 feet and St. Peter sandstone at 17 feet. So right off the bat, we knew, wow, we got some really challenging conditions changing dramatically. Below the fat clays, at least we have some nice sands, but you can see one side of the building's got really shallow bedrock, the other side 120 feet down to get to bedrock. So I drew up this this beautiful cross section. And cutting the site from west to east, you can see you've got the urban, typical layer urban fill at the top. On the east side of the site, you've got your limestone and your shale, and then St. Peter sandstone just dropping off into oblivion. As you move across the site, we do have a nice pocket of sand kind of in the middle, but then you've got these very soft clays over about 1/3 of the site on the east end. At depth, we've got nice glacial soils, a lot of cobbles and boulders, which, you know, you start looking at combination piling systems, like these are going to be challenging for pile installations because they created a lot of, our drillers loved trying to get through this at 100 plus feet deep. You got cobbles and boulders and we got to find bedrock. They love that phone call. So yeah, so you get this, this is the typical cross section across the middle of the site, and it's pretty similar to that generalized geology map, except for this is a relict Bassett's Creek channel versus the Mississippi River. So the foundation system, all those variable conditions, we end up with basically everything you could imagine putting under this building. Here's your residential tower. Here's your podium. You can see the tunnel down here in this picture. We ended up with a combination of H piles, pipe piles, cast in place drilled shafts, spread footings, more H piles, and we'll get into it later, but we had to switch some to micro piles. So we've got all the different kind of foundations you can imagine. Our H piles are high capacity, 300 working tons. HP 14 by 117s. Contractor or the designer ended up on those for their load carrying ability for the high loads, combined with hopefully they could penetrate the boulder layers at depth in areas to help with drivability. The pipe piles where we use them are just conventional 12-inch diameter concrete filled steel pipe piles. The cast in place drilled shafts had a 3-foot socket into the sandstone with anywhere from a 3 to an 8-foot diameter. Spread footings. We had spread footings throughout the central portion, as we'll get to, but we had, based on pressure meter tests and our borings, 8,000 PSF for our central part of the building spread footing. So again, when you look at the variability of foundations, I don't know if you could find too many places in one quarter of a city block that has this kind of variability. So here's our foundation plan. Again, Project North is this way. This is where the railroad would be. You can see the tunnel cutting through the site here. Our primary H piles were, hit the first one, in this area. This is our residential tower with kind of this west leg of the structure, because of that fat clay zone is basically running right through here. As you hit that really deep zone of very soft clays. This is kind of the highest loads with the biggest part of the tower. You can see the elevator core here. That's a lot of 300-ton piles driven in a pretty small area. So the blue is our office tower. So you can see most of it is under cast in place drilled shafts. Anywhere again from about 3 feet to 8 foot diameter drilled shafts. This is the elevator core for the tower. Basically taking up that whole, eastern half of the building. And then the central part where it was just the podium, we were able to chase out those fat clays in areas and put the spread footings right on the nice sand. Once we got down to basement grade, we had spread footing pads under this central portion of the building, with some on native sand, some on soil corrections. Patrick was out for much of that part of the work. So again, when you've got power rigs and caisson rigs going on either side of you, it's kind of funny to be doing a soil correction for a spread footing right in the middle. So the next one. This was the only area basically that we had the pipe piles. The lighter loaded portion of the podium that kind of encompasses this part of the footprint again. I kind of forgot this is H piles. I didn't put that in my rectangle, but lighter capacity because of the just the podium loading, but this was the pipe piles in that area. And then I will note, we do have grade beams where this tunnel is situated. The piling systems had to extend below the tunnel to transfer the load below the tunnel on both edges. You can see this tunnel is about 25 feet down, and then it hits the drop structure right there, and it's almost 50 feet below grade here. So these piles had to extend to considerable depth through the bedrock just to get the load down below the tunnel. That ended up being not necessarily because we're loading the tunnel. The city required that at any point in time, if this tunnel had to be maintained or removed, that they have access to it. And they didn't want to run the risk of building foundations be impeded. I can't imagine the situation where they have to remove this tunnel, but it would be a problem. But they had to put in 7 grade beams. There's one running this way, there's 3 this direction, and then there's a second level foundation plan that's got 3 more, but they have grade beam loads that span that tunnel and then transferred the load down below it. Like I said, the city was pretty adamant on making sure that worst case scenario, that tunnel could be removed or maintained and not have to impact the building. So every structural engineer's dream, I'm assuming. So here's a 3D footing plan that the structural engineer put together. I don't see many of these, so it's pretty cool when you actually put it in footing view. So here's the target fields over here. This is the box culvert running through the north side of the site, cutting through the corner of the building. There's that drop structure. So you can see we've got those big grade beams spanning the tunnel. This is all high capacity H piles.
What's that?
What's that?
Sorry.
No. Feel free to chime in. It really is at the end of the day. They actually have the second.
So since I made some noise, I mean, that looks like the airport where we put the light rail and then they build a parking ramp over it. And so CNA and other people had to figure out how to build a parking ramp on top of a tunnel, but it's the same stuff.
It's pretty cool. I mean, we can do some pretty ingenious things when we put our minds to it. But this vertical drop structure on the second floor of the podium, they have an access room that they can get into to do cleaning, to do maintenance. We sent people down in this tunnel multiple times throughout the project to do inspections. We'll touch on that here in a little bit, but before this site was built, it was just a parking lot with a vault cover on the top. And you can go out on that, you could go in the parking lot and stand on it, and it sounded like you're standing on top of a waterfall. Because it's basically just a constant flow of water going down and dropping 25 feet. And it was kind of eerie when you realized what was underneath you. But as you can see, these drilled shafts extended down deeper. Some of these right here, I think, ended up getting extended later because of, again, design reasons to get loading down below. Our spread footings were in the kind of central portion here. I think it's pretty cool they can even draw this picture. It really helps when you get your structural engineering plan package and you pull this up and you go, oh, that's what it looks like. It helps than just looking at the dots on the surface. But as you can tell, there's a lot going on. There was also, and I don't really have a lot of information on that in this presentation. I apologize. I realized this at the end, but the temporary retention system had to run all along this north side and then go over the tunnel and then keep going. So the way they kind of carried the load over the tunnel and distributed to either side is, you know, again, if I was designing a temporary retention system, that would seem like a super challenging thing to do. So now we'll just I'm going to run through a couple of construction photos. So to kind of put it into perspective, you can see we're looking north. That's the Ford building. There's our two overpasses of 5th Street and 4th Street. Site lies right in the middle. You can see Bolander is mobilized and started getting piling on site. They've done some clearing. You got the train in the background. This is the alley with the Met Council interceptor that runs through it. So again, you can just kind of see the tight confines of everything they were dealing with. Even for an urban site, it had a lot of challenges with just logistics and moving things around and just working on this property. This is the retaining wall, temporary retention starting on the side by Target Field. This is looking back the other direction. You can see the bike trail, maintained operation throughout. They're just now putting the cover on it to protect the bikers. The railroad tracks here, looking back, this is, I think, December 2021 when they first started driving piling. So again, they had 2 different power rigs working. They ended up having a caisson rig. They had soil correction excavations. Like, there was a lot going on in this little piece of the world for about 12 months. Here's some excavation work. As you can see, these grade beams were substantial. I think they're anywhere from 6 to 8 foot thick, was the pile caps and grade beams for the residential tower. As you can see, we've got our pile caps in. We've got excavation work. This was part of the soil correction in the central part of the site. Here's a couple of pictures Patrick took. You can see it was about as night and day when you're doing an excavation. You got your fat clays and you got your nice sand over on the other side. You can see just the transition, correcting out that very sticky, nasty clay was pretty easy when you've got that stark of a transition between conditions. This was just some backfilling going on. You can see after the corrections are done in the middle part, columns going up, pump trucks. You still have pile rigs. You had caisson rigs on the other side. You got excavators. It's pretty remarkable they were able to operate all this stuff at the same time in this one little area. This is a micro power rig. As I mentioned, some of the piles ended up getting switched because of some groundwater challenges and some installations. So there were some areas where they actually switched over from drilled shafts to a micro power rig. These guys look like they're looking at something really intense. I wish I knew what it was. But they are definitely focused on something towards Target Field. This was the tower going up. I've got a bit of a lag because obviously we get involved with foundation work and then we're not there as much, but this was the site. you can see this is the office tower going up. This is 4th Street. That's our major elevator core in the middle. And that's the residential tower with the PT decks going up in the background. This was probably December 22, I think. This was a steel worker, Dan Graham, our steel guy, took this picture. I bet he takes a lot of really cool photos that we never get to see. It kind of makes me queasy because I'm moderately scared of heights. So just watching these guys walk around is pretty incredible. But this was just the steel going up for the office tower. Again, the work those guys do is great. And I just love seeing photos of them. Here is our amenity terrace going in to connect the 2 towers. Yeah, that's kind of the marquee feature. Fun fact, they started with this having an outdoor pool overlooking Target Field. And then I think somewhere in the design phases, they realized it's Minneapolis and it's probably not the easiest thing to do. So that the plug got pulled on the pool, but they will have an outdoor terrace on both buildings. There will be a bar and a restaurant, and it's probably the closest thing we've got to like the Wrigley Field look in from the outfield. So hopefully we'll be able to get up there sometime. So
That's where I think we should do our next meeting.
let's go. 2025, let's go. So a couple of construction challenges. Again, this was a really big job, a lot of moving parts. Overall, it seems like the construction challenges were pretty manageable, but there's never not hiccups. There's never not something that goes on. One of the things I would say was the Bassett Creek tunnel inspections. The city required inspections to be done before, during, and after construction. We have not completed the last one yet. We've been in the tunnel 5 times so far. They also required us to, which is a good thing from a safety standpoint, but we had to have a life and safety consultant, which I didn't even really know was a thing. But we had to have rescue and EMS personnel on call while we're in the tunnel. Our guys, we've got pictures from in the tunnel, but they're just flashes and black concrete. It's just like, okay, these aren't very good. But they only did the top part of the tunnel. We didn't drop down into the lower section. That would have just been a little much. But yeah, so we had sensors in there. We had crack monitors just to confirm that there was no movement going on. Thankfully, to date, we haven't seen any distress or any movement of the tunnel. Yeah. No, there was no, I think we removed 10 feet of overburden over it, and there was still another 10 feet of cover over the top.
They are excavating to the top of the Bassett Creek tunnel.
Oh, sure. Yeah.
So there's actual buoyancy.
I can see that. Yeah, that was discussed. Yeah, that was discussed when we did the geotech, and at the end of the day, I think we still had almost, 8 or 10 feet of cover over the tunnel. So that was not a concern. But yeah, to date, we haven't seen anything, but again, that was pretty challenging. We've had, is Ren here? Where's Ren? You did this, right? So there's our guy going in the tunnel, man. So, yeah. So, and then Jonas, the other guy, he's not with Braun either. So I don't know who's going to go in the tunnel now, man. Thank you. I was going to nominate Patrick. So yeah, if anybody has more questions about the tunnel and the monitoring and all that, ask Ren, because he was boots on the ground for most of that. So one of the other things we had was the temporary retention on the west side of the site along Target Field. It's pile and wood lagging. There was some displacement and settlement, especially within the Butler building, which is kind of under the overpass part of Target Field, an independent building. They had a lot of the exterior concrete flatworks just started moving around, and I went out there a couple of times with a team looking at it, and there wasn't a whole lot of rhyme or reason where you usually see your temporary lagging kind of bow out. And long story short, at the end of the day, they decided it was easier just to replace all the flatwork for that part of Target Field than to try to diagnose the problem further. But we did have to do additional monitoring and observation to make sure there wasn't a deeper problem beyond just the flat work. But that did kind of ruffle the twins' feathers there for a little bit and, yes. So, but again, like I said, at the end of the day, I think it just kind of, it was like, well, it's just easier to fix this than to keep looking at it. So there was no bigger problem. So, you know, yes.
Did you guys have problem with water table, just along the lake? Right, did the water table come down and?
What, we didn't see any movement of the water table. I think, you're preclude my next slide as far as there were some challenges with the water table on the drilled shafts. But we didn't see a whole lot of bounce in it. You kind of have that central part of the site where the sand is and you hit the water at 803 and can create some challenges, but we didn't see any changes in it. We looked at possible, you know, basal heave and some other things. And I think at the end of the day, instead of keeping out, you know, analyzing it, it was easier to just replace and fix the problem. So sometimes you just kind of go, well, let's just fix it at the end of the day and stop looking at it. So. Another thing, at the start of the job, we had some low strength concrete that threw a huge curveball at our structural engineer. So there were some columns and walls within the podium. My understanding, it was kind of a new green mix concrete and it had a hard time. It did not achieve long-term strength, and it was 6,000, 8,000 and 10,000 KSI mixes. So when you're talking about a 40-story tower and high strength concrete in the core, it's a big deal. So the engineer ended up, structural engineer modified the cylinder pattern. So this was the first time I'd ever seen this as this is the number of cylinders we had to get. And we did this on, Patrick, how many sets? Oh, I thought it was like 500. So we went from 5 sets to 12 sets. So we had the, 5 cylinders to 12 cylinders. So 3 day, 7 day, 328s, 356s and 84 and 3 holds. There was also coring that was done to further evaluate strength. Several columns had to be torn out and replaced because they just couldn't confirm long-term strength. So then this casting cylinders pattern continued till we got halfway up the residential tower, and the structurals felt concrete about, or good about the new concrete mixes they had and could pull the plug on it. But as you can see in our world, that was the biggest change order I've ever seen associated with concrete cylinders. So it's like, usually you're kind of like, oh, we got to take a few more cylinders, no big deal. Oh, we have to take 7 more 500 times. Like, that's going to be a lot. So, yeah, so that was kind of a big curveball as far as a structural design, and just, you know, right off the bat, when your concrete's not green in strength, your structural engineer gets just a little geeky on it. So
Do you know if that was the type 1L cement?
I don't recall. I'd have to look that back up.
Big deal with tieback.
Yeah. So I know this was their first time using this mix, and I don't think it was the best time to use this mix the first time. So yeah. He did not like maturity meters. Did not want to do that. He was and he wouldn't accept 1 cylinder for additional day breaks. He had to have sets of 3. For sure. That was discussed, and he wanted cylinders. So so
We sell cylinders.
we sell cylinders, man. Yeah. Kat, you got a question? Most of these were not broken, but he wanted them because if they had to go longer than this, he did not want to accept 1 days, but he would accept 1 day. Yeah, 1 cylinder at 84 days. He would accept that, but he really liked this 3-day set. Yeah, when you just had 1 56-day, he's like, nope, I can't take that. We got to have 3. And it's like, okay, well.
Big building.
It was a big building, high risk, but they got it figured out. But they did have to tear out several columns and replace them as part of this. Yes, sir. They were 4x8s. Who supplied the cylinders? Aggregate Industries. Of course. I didn't say that. Alright. So then deep foundation modifications. Again, I don't have a lot of pictures on this, but we kind of alluded to it. As they worked around the tunnel and they had groundwater issues within the cast in place drilled shafts, the contractor did decide to switch several of the shafts to H piles and a few to micro piles. Basically at a cost even, just because they were having a hard time in the sand and they didn't want, they were having problems getting them to depth and they just didn't want to mess up that tunnel. So there were some pretty substantial changes. I want to say there was, what was it at the end of the day, like 15 of the shafts got switched over to H piles. But yeah, so that was a pretty big change. They were right along the tunnel, just to aid with, or to aid in constructability and to avoid any potential impacts. So, again, it was kind of a contractor decided decision. If they could get the same capacity and do it in replace of the, drilled shafts, then seems fine to us. So,
Just on that thing, what was the cost? So the trade-off cost wise was that, I mean, it was that the contractor said, this is a smart thing to do, there's no cost impact or.
Yeah, that's where the conversation started. I don't know where it ended. So that was some later follow-ups with Kraus Anderson and the owner as far as the delta, but we went into it with it being a even trade, and it may or may not have ended up in that at the end of the day. So I don't know how that ended up, so I don't really want to. I don't want to allude to it too far. So.
Minneapolis, but, no, done some work downtown and they've always been kind of sensitive to pile driving because of the noise and vibration.
Very
Get a
sensitive.
waiver for that over this project? Or?
No, we had vibration monitoring. We didn't have to do noise, but we had a lot of vibration monitoring. Again, that was Ren's baby for a long time, but yeah, they definitely had.
Issue with it, a problem.
We didn't have anything that was concerning, no. So then stormwater management. When you look at where do you put water in the city, thankfully between the 3rd Street and 4th Street overpasses, there's a nice big pocket of sand. So for the T3 building and North Loop Green, we buried underground infiltration chambers, which remarkably, when you got a site that's half bedrock and half fat clay, how do you end up with sand right where you want to put a pond? It's pretty good luck. And it's funny, they turned it into green space. I took this picture last week. A new definition of green space is AstroTurf. So I was like, oh, it's going to be a park. I went down there. It's green as it's ever going to be. It looks like Augusta out there, man. It's just like, we have green spaces that are now just AstroTurf, and I don't know how that works, but as part of this, we had to prove so you got your overpass foundations, and MnDOT raised a stink because they were concerned about settlement of infiltrating water. Yeah. Infiltrating water impacting their bridge foundations, which are on 100-foot deep pilings. So, again, it wasn't a huge argument, but it was something that took quite a bit of back and forth to convince them that it's not going to affect your bridge. But there are 2 different systems here, buried underneath this part of the site, and one feeds T3 building and one feeds, North Loop Green. Again, that's probably the luckiest thing they got with all of the bedrock and all the other challenges was they had 50 feet of nice sand right where their, stormwater went. So they've got a cantilever function on the 1st floor of the building. And actually all 3 of the buildings that they built down through here, have this. When you're on the railroad side, the city of Minneapolis required so this trail is currently within the right of way of the railroad. So if the railroad decided to take this and put more rail here, they required them to put a cantilever to make sure they could put another bike trail under the building. And the pilings or the piers for the building had to be designed to withstand a train impact. So, yeah. Under the slight chance that they're gonna move this rail over. So again, all the columns over here are designed, I can't remember the speed, but they have to be able to withstand a train impact, and they can run a bike trail all the way along this corridor because all the neighboring buildings that they built have this same cantilever, so. And I don't know, I'm not a structural engineer, I don't cost these things, but I know every time you do a cantilever, your cost goes up exponentially. So they're already cantilevering over the tunnel, and now they have to cantilever to make a bike trail. So
Maybe, but.
a maybe bike trail that's probably never gonna happen. So as you can see, this is an artist rendering showing there's your bike trail with lots of people going on. One cool feature they do have, which is hard to photograph now because it's not done, for pedestrian movements kind of through the site, they did incorporate a nice big grand staircase that goes up from the bottom through the podium top level and over to Target Field. Kind of nice. You run into a lot of spots in downtown where you just hit a building and you got to go around through. So they did incorporate a very nice pedestrian kind of movement through the site here. So kind of nice. So next. This was another finished product, and you can see, I think it's 21 feet at its closest to the 4th Street overpass. I don't know what they usually require, but it seems pretty tight. So yeah, when you get down there, you look up and you realize like that at its closest point, like that, you know, it's two truck widths away. So very tight. Again, when you're looking at how they went up vertically with that site, it's amazing how they shoehorn that thing in that small area. This is the view from 5th Street. Tower almost done now. It's the fully facaded. They're just doing interior improvements right now. This is Target Field. There's light rail. There's a vehicle and pedestrian entrance here. There will be retail and restaurant on the 1st floor, and you can have access right here to the main level. So yeah, when you're at Target Field, it's a nice new, definitely skyline changing feature when you're in that part of downtown. This is the view from Target Field. So this I pulled from the architect site. This I took at a baseball game last year. And I was just, they did a pretty good job depicting what the thing's going to look like. So it was funny. I had this picture and then I found this one. I'm like, oh my God, it's perfect.
You should have had your seatbelts.
I should have, if I'd have known what this looked like, I could have cropped in a little bit. So, but you can see it is, this is where that amenity terrace level is. I think they were still a couple of floors from being topped off at this point in time. But it will have a very nice view into the stadium. And obviously when you're at the field, it changes the skyline dramatically. So, and this is your construction workers watching a game. So you can see you got a beautiful view of downtown. I don't know what floor this is on, but it's a very nice view into the stadium. Watching a game. You can imagine from what I did some research, and I think I was talking to Emily about this earlier. Anywhere from, I think a 400 square foot studio is almost $2,000 a month on a lower level. And the top floor penthouse, which is just over 2,000 square feet, super huge, is $12,000 a month. So, yeah, sure. So yeah, but that's yeah, that's the view that $12,000 a month will get you. So 4 months of the year you can watch baseball. So, and then this is the last slide I got here. This is from Twins opening day last year. I pulled this off of good old Instagram. You mind popping the video? There's a video on that link. Can you see if it'll work? Should be able to click on it, but. Maybe.
Dramatic pause.
There we go. So this was Jake Watzak. So this was the construction workers. They had an F-16 flyover, and can we get the little button bar or the sound bar?
Put the audio right there. Yep, right there.
Oh, I don't think you actually.
Oh, we don't. It's amazing. That's really close. So, I saw that online and I was just like, man, that's a great video. I'm totally stealing that one. But that was posted by some construction workers from the team that filmed that on opening day last year. Pretty cool. I mean, that talking about flying at deck level, look how low they are. Yeah.
It was loud.
So the sound's really cool. But yeah, I mean, it almost be a little spooky when they came by.
Yeah.
So so that's my presentation. That's what I got. It's kind of our North Loop Green in a nutshell. And yeah, open it up to any questions if anybody got anything in the back. H piles. Yep. It fell right in the middle of the worst part of the site. Yes, sir. How wide? Deep, they were like 6 feet thick, and most of them were probably 10 by 10s or 8 by 10s, something like that. They're pretty substantial. So yes, ma'am.
The residency and the office tower, given that occupancy and retail, whatever, retail spaces and office buildings is pretty down.
Yeah. So that was a huge thing. I mean, we finished our geotech on this in 2020, and they approved this for construction late 2020 during COVID. And I think everybody, when they approved this, were like, you're gonna spend $250 million building what? Where? So yeah, I mean, they've got 450 rental apartment units. I think there's 100 of them that are considered short-term. I don't know what that means. And then 350 of them that are long-term. But yeah, they have 450 rental units and I don't know how much, 350,000 square feet of office building, I think is what it is. So it's a substantial amount of office that they approved post-COVID in a get out of downtown kind of world, but their people are smarter than I am, and they figured it out. So, and supposedly talking to the Hines guys, they have a substantial amount already leased. So, supposedly Alex Rodriguez is looking at moving here from the Gateway Tower. So, but I think that would be it's a better view, but probably not as nice of a unit. So, yes, sir.
The temporary timberline, did all that come out?
Yes. It's all been pulled out. Yep. Yeah, I guess I probably should have touched on that. From the previously existing parking lot, there's one level down and then it goes up from there. So there's only one full level basement and then everything else is above grade from there. So.
That parking lot's pretty.
Yeah, the parking lot, like if you've never been down in that parking lot before they built it, when you dropped off of, what is that, 3rd Avenue there? I mean, you go down almost 30 feet. So they had to get 4 stories of podium up to get to street grade at 5th Street. So you've got three stories and 1 basement grade just to get up to what's perceived target field grade in that part of town. Yes, sir.
What is the long-term monitoring? Is there any long-term ongoing monitoring of the building for performance?
As of now, no. I would think maybe if there's an issue, but right now, the only monitoring left to do is the final tunnel inspection per the city. And then, you know, if it's performing status quo, then nobody's gonna look at it anymore.
And on a proportion basis, was this a more expensive foundation or less expensive? Or like a tower? Would you consider this
I think it was really expensive. I don't know what the bar is on that, but I would think it was, yes. That was one of their huge driving, their cost analysis that they were working on forever was how to balance out the foundations. And I think it was more than they even thought it would be going into it. And we've kind of prepared them for do deep H piles across the whole thing. So, and I think it ended up being more, just with site constraints and everything else that went into it. I think it was a huge cost. So, yes, sir.
Maybe, so following up on that last question. And because you're, well, partly because you're from Tennessee, I guess.
Uh-oh, that's a loaded question.
This site, you're not very far from Target Center, the basketball arena. That was built, I don't know, but I mean, when 30 or so years ago, when it was built, that was good. I sat in a presentation probably from Worthington that talked about Target Center, which is sitting on the edge of the valley of
Mhm.
the old Glacier River. So you're out in the valley.
Yep.
Anyway, this is all kind of known information. So back to the scoping. Somebody should have known. They should have had a pretty reasonable idea of the challenges of this foundation. That's my question.
We had those conversations with them
Okay.
6 years before they built this building,
Okay,
so.
thank you.
So when I mentioned they did two, this is they call it North Loop Green 3 because it's their third building in the North Loop. But they did Dock Street Flats, T3, and then this one, anybody here knows Ray Huber?
Yeah.
So I did all this work with Ray Huber. So yes, when we started looking at this, there was a pretty good handle from the start at what we could hit and how bad it could be. So again, from day one, we prepared them for worst case scenario versus best case scenario. So we had a similar condition. You go to each of those other buildings and there's a combination foundation system between spread footings and pilings on every building down through there. And it's kind of funny when you map it all out, you can kind of see the bends and the flows. But yes, to your point, I think the table was set about as good as we could ahead of time. So, yes, sir. Yes.
Cantilever portion of the building with the potential future Cedar Lake trail or the trail that comes through there. You're looking at some column elements connected between the ground and the building yet. So what is the function of those columns with the cantilever portion of the structure?
Maybe cantilever wasn't the best word for that. Good catch, good catch. Maybe we should just call it dead space. Building dead space, so.